Standard 6 is writing equations from tables, and Standard 6.1 is specifically I can write an equation of a line from a table of values. So we're talking about lines today. And we're looking at linear functions, and we're going to use point-slope form today. Point-slope form may be less familiar to some of you, so we'll be reviewing that. But there's some times that it is easier to graph or write equations given point-slope form or writing it in point-slope form. For example, look at this line right here. For slope-intercept form, y equals mx plus b, you would need to know the y-intercept. And the y-intercept here is somewhere between 4 and 5. That's not really going to be a nice value to have to try to figure out accurately to be able to write our equation. However, there are all of these distinct points here that we could plug into this equation with nice integer values. Let's review the parts of point-slope form. We have m, which no matter what type of function we're talking about, that is our slope. And we have x1, y1, which is a point on the line. And that will look like x1, y1 as an ordered pair. Remember that slope is the change in y over the change in x, or rise over run. Let's look at the line and look at the coordinates of the ordered pairs that are along the line, and we're going to choose one of those to put in our equation. Any of these points would work to plug in. We'll choose one when we're writing the equation. We also need the slope. Count the rise over run, make a slope triangle. You can see here that the rise is 2 and the run is 3. I'm going up 2 to the right 3 to get to my next point. So my change in y over my change in x or my rise over run is 2 over 3. Looking at our equation, y minus the slope value, that's something we're going to plug in for right here, times the quantity x minus the x value plus the y value. So I put the basic equation here. Our slope is 2 over 3. So I'm just going to plug that in there. And we're going to pick one of these points to plug in. I usually like to pick positive points because then I don't have to worry about extra negatives. So let's just take the point 2, 6. And it would be x minus 2 and plus 6. This is just kind of like the HK value that we had when we did vertex form of quadratics with that built-in negative there. So this is the equation of this line. We're going to use that form when we're writing tables because it's also easier there if you're not given the y-intercept. Now we're going to transfer that knowledge of writing equations from a graph to writing equations from a table. And I have some steps here. First, we're going to write the slope from your table. And we're going to talk about how to do that. Second, we're going to pick any point from our table. Third, we're going to take the slope and point and write our equation. So we're going to look at this table. To find the slope from the table, hopefully you will recall that that's going to be our rate of change. And so to get our range of change, we're going to have to look at what is our change in y and what is the change in x. So you'll notice from our table that this would be a linear function because your change in y is constant and your change of x is constant, which means you have a constant rate of change. We're going to write that in this box right here. Rate of change is your change in y over the change in x, and in this case it's 2 over 3. That's the same as the slope. Now we're going to pick a point. You can pick any one of these points. You might recognize that these ordered pairs are all of the points that we found along this line. So this table is a table of all the points along this line, and I think it makes sense to pick the same point that we used above just to show that that works and it's the same, which was 2, 6. Any point would work though. and then we're going to write that in our equation. So I'm going to write the equation on top so we can refer to it. So y equals our slope, 2 over 3, x minus my x value. So this is a point, and we're going to use it as x. We put the subscript here to show it's a specific point. We're using 2, 6 as opposed to a variable which represents any x and y. So my x value is 2 plus, because I have a plus right there, my y value, which is 6. And we get that same equation. Flip your paper over and look at the group practice. First step, find the slope of from the table. Second point, second step, choose a point from your table. And third step, use that slope and point to write your equation in point slope form, unless you happen to have the y-intercept, which you can use that form as well. Always rewrite that general form, that point slope form, so you can refer to that easily when you're writing your equation. Step 1, let's find the slope from our table of values. So I want to show here on a number line, when you're going from -6 to -5, you're actually increasing by 1 because you're going to the right. So, and same thing with your -8 to -3, -8 to -3 is going to the right 5 units. That's why these are increasing. So you can see that we're increasing by 5 here. It's easier to see you're increasing when you're in positive integers. And so our rate of change is going to be the change in y over the change in x, which in this case is going to be 1 over 5, or 1/5. Now we're going to choose a point. Everyone could choose a tipper point, and they would have an equation that looked like the same form. Looked different even in point slope form. But if we simplified it to slope intercept form, you would see that they all come out to be the same. Let's choose this first point here of -8, -6. I don't have any choices here that are in positive, and this way I can show you what happens when we have a negative here. So y equals our slope, which is 1 over 5. Now I have x minus, and I'm subtracting -8. So because I'm subtracting -8, I can put that in as subtract -8 like that. But when you're subtracting -8, that's the same thing as adding +8. So often you'll see this as x plus 8 like this. So we'll write the equation twice. And then we have in our equation plus y1, and our y1 value, our y value, is a -6. So you can put adding a -6. And when you're adding a -6, you often would just write that as subtract 6. So you can see here that from my point, you have opposite sign here. This -6 shows up just like subtract 6 in your equation. So very much like the HK situation for vertex and vertex form for quadratics. Looking at number 2's table, start with step 1 and find the slope from your table of values. When I'm looking at my change in x and change in y, from -4 to -2 is going to the right 2. From -2 to -1 is going to the right 1, so that's plus 1. And going from -1 to -2 is 1, 2, 3 units, so it's increasing by 3. And from 2 to 4 is increasing by 2. So you see we have different values in here. That doesn't mean this is not a linear function, but we do need to see what the change in y is. And so here we're decreasing because we're way over here at 9 and we're going to 1. That's decreasing by 8. From 1 to -3 is decreasing by 4. And we're going to be off of our chart here, but from -3 to -15, you see that we're decreasing, and we're decreasing by 12. And by -15 to -23, we're still decreasing, and we're decreasing by 8. So imagine that number line in your head, or even sketch out a number line. Or if you look at the back of your packet, you have a bunch of number lines that you can write on of different sizes, different scales. so what does this mean for our slope? So if we're looking at our rate of change, which is the change in y over the change in x, we have to look at each individual change in y and change in x. So this one is -8 over 2. This right here is -4 over 1. This here is -12 over 3. And finally, we have -8 over 2 again. So the first and the last are obviously the same because of the same number. These can reduce. -8 divided by 2 is -4, and you can put the 1 underneath if you want, but normally when you simplify it, if it has a 1 in the denominator, you would write that just as -4. Well, -4 divided by 1 is also just -4, and -12 divided by 3 is -4. So since these are the same, we know that this is a linear function. Which we would imagine since that's the section we're working on today. So our slope up here I'm going to write is -4. Now we're going to pick a point from our table, and we can pick any of those. You know, some students might want to pick -2, 1 because they're nice small numbers. Some students will always just pick the top one. It doesn't really matter. I'll just go with that top one of -4, 9, and write that in your equation. So I would have here y equals -4 times the quantity x minus -4, which is the same as adding 4, and then plus 9 for that point right there. Since we have a nice slope to work with, I'm going to show you that if we used a different point, like -2, 1, we would it would look different in point slope form, but if we simplify that to slope intercept form, it would look the same. So if I selected -2, 1 as my point from right here and put that in, I would get y equals -4 times the quantity x minus -2, which is the same as adding 2, plus 1. And to put this in slope intercept form, I can do a little algebra. I could take and distribute that -4 and multiply it across there, and that's going to give me -4x minus 8 plus 1. And if I collect like terms here, I get -4x, and then the -8 plus 1 is -7. Let's do the same thing up here. So -4 times x is -4x. -4 times +4 is -16 when I distribute that, and I still have the plus 9 out here. Now I add the -16 and the 9, which gives me y equals -4x plus 7. So this would be point slope form. This would say that I would go through the point 0, -7, and have a slope of -4.